What is going on, guys? Welcome back to another video. In today's video, I will show you how to solve a free response question or FRQ on the Calculus Advanced Placement exam. Now, for those of you who are not familiar with Advanced Placement or shorthand AP, it's basically a program here in the States that allows students to earn or qualify for college credits in high school, so that can save them on tuition costs and basically skip courses in college that otherwise they have to sit through. Oh, I mean, if you already know that in high school, why not? So I feel like this is a pretty cool program, but to get those college credits, you need to take a test at the end of the year, and this video is preparing for a section of a test of a subject of an AP exam. So pretty specific. Follow along if you want, but chances are if you clicked on this video, you probably want to know how to get a perfect score or close to it on the AP Calculus exam. And yeah, so let's just get straight into it. This question will be, again, described on the title, so if you want to search up what question that is, it will be in the title. But let's just get straight into it. Normally, you'll have 15 minutes to do each question, approximately. If you do it faster, that's good on you, but normally you get 15, but I will spend probably more than 15 trying to explain this. And for those who know about the AP exam and are planning to take on it, note that this is a very different experience because normally math just requires you to get the right answer, but this you must also kind of like justify and yes, sometimes even write sentences in math. I know, disgusting, right? But this is what they want, and if you want to get the full points, basically you have to follow this. Alright, let's get started. Enough wasting time. Alright, first we are going to take a look at part A here. So, it tells you that the continuous function f is defined on the closed interval -6 to 5. Now, the graph shows -2 to 5. So, make sure you catch on to that because some people will assume the graph is all of f, and that's not true. There are section of f obscured. So, the figure above shows a portion of the graph, yes, a portion, consisting of two line segments and a quarter of a circle centered at the 0.53. So it tells you it's a circle, so don't assume it, just you know it's a circle, because it said it. Alright, now, it is known that the 0.3, 3 minus square root of 5 is on the graph of f, so that is kind of like right here, if you can see my crosshair. But A, if the integral from -6 to 5 of f of x dx equals 7, find the value of -6 to 2, the integral of that. So, show the work that leads to your answer. So you can't just say, oh, figured it out in my head or something. Oh, by the way, this question, if you do go to it, is on the no calculator section. So, just an FYI. Alright, let's do A. So, first thing you need to identify is, you know that -6 to 5 is kind of like the full defined interval, right? It's just -6 to 5. And then you know that -6 to -2 is the portion of the integral from -6 all the way to this point right here. So that's kind of like the unknown portion of the integral we're trying to solve here. So you must know that in order to get 1 point. So let's do that really quick. -6, 5, not 4, and then f of x dx equals integral from -6 to -2 f of x dx plus this section right here. So the integral from -2 to 5 f of x dx. So that is what you must know. Otherwise, you won't get it right. So now that we know this, let's just copy this expression. Again, you have to write it, but I'll just use copying because for time's sake. But we know this is 7 right here because it said it right up here. And then we replace that. This is unknown. And this. Alright, now what about this? Okay, this integral we can solve by looking at the graph. So, first, we can see that a portion right here shows that we have this portion right here. So that's kind of like you can kind of visualize in your head. This is kind of like 4, right? 4 squares, but slice down the middle. So that's 2 right there. But then you have this little section minus down here. And then you have this section up here. So you have these sections, and you have this point at 2, 3 with a kind of like a semicircle, quarter circle, with the center again at 5, 3. So basically with that, you can kind of determine this integral using the squares or the grid lines. And for the circle, you can see that the radius is 3. So we can square that to get 9. And obviously, pi r squared. So the area of the circle is 9 pi, or 3 squared pi. But it said quarter of a circle, so divide that by 4. So that we can solve this to be 2 plus 9 minus, get my fraction symbol out here, 9 pi divided by 4, because the circle isn't complete. It's just a circle here. And then also, here's the deal. Why do we do 9 minus? Why isn't this plus? Well, because we're not trying to find the circle's area. We're trying to find the stuff underneath it. So if you can see, the circle is kind of like inscribed in a square with area of 9. But it is, see, from 2 to 5, that's 3 above. So this is 9 squares. So I don't know if you guys can see, but 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, 9 squares. And then we want minus the chunk you carve it out of here, which is 9 pi over 4. So we want minus the circle's area to get this little sliver down here. Again, area under the curve. Okay, remember that. All right. So next, we can see that. Let's just subtract this to this, since this is the total, to get the final answer. So let's just reorganize this a little bit, and then we'll do this equals this minus this. So 7 minus 2 plus 9 minus, so 7 minus 11 minus 9 pi over 4. So, which then just equals, keep on exiting out of equation mode, 9 pi over 4, which equals 9 pi over 4 minus 4. And that is the answer. Is there extra space here? Yeah. Alright, so that is the answer. So, that is part A, and boom, you're done. That is all the points. Yes, you'll get all the points. Where are the points? Alright, let's highlight the points here. So, let's see if we can highlight this right here somewhere. Alright, yeah, okay. So first point is you have to know that this integral is composed from these two. So I will highlight that, I guess, orange. Oh, that changed the text color. Highlight orange. That also changes the text color. I think that's what equations do. Alright, let's just roll with that. Alright, so that's 1 point. I'll change colors, but yeah. The second point is, actually, you know what? Basically, second point is knowing that -2 to 5 is this integral, and knowing that it's 9 minus 9 pi over 4 because you subtract it. So that's the second point, and I will highlight with green. And that did not work. Let's try again. Maybe not strong enough. Yellow. Okay, it doesn't matter. I'll just annotate that. So, knowing that this is 1 point, just this section right here, and then finally the answer, 1 point. So total, this is a 3-point problem. So yeah, you'll get all 3 points if you do the orange, get basically just if you get all these 3 lines, you're fine. All right, part B. Part B says evaluate. Oh, it's just a simple integral. And that's pretty much it. So we just solve it, right? Well, yep, we just solve it. But we need to make sure we need to know what we're doing here. Otherwise, we will get 0 points because we get the wrong answer. All right. So what we can do is we can see that part B wants the integral of the derivative of f of x. That must be screaming to you the second part of the fundamental theorem. So let's just write that here. The integral from 3 to 5 of 2 f prime of x plus 4 dx equals. Alright, and now we know that again, the second fundamental theorem, so the integral and the derivative cancel out. But remember, 4 needs to be kind of, 4 is just there, so we gotta make sure that we remember what to do with 4 here. So it's just 2f of x plus 4x, because again, 4, the x needs to be tacked on. And then evaluate it from 5 to 3, which then just equals, if I can get this right, again, fundamental theorem on all sides. We're using the first part now, so f of 5 plus 20, because you plug in the 5 minus 2 f of 3 plus 12, and that just equals 2 times, okay, I guess, yeah, times 0 plus 20 minus 2 and f of 3. This is where that point comes in. Remember, everything has a point, I guess. No pun intended, but 3 minus square root of 5, because we're evaluating f of 3, and it tells you that the point at 3 is 3 minus square root of 5, so that's where that comes in. This should be in parentheses. No more f, right? Why am I doing it? Okay, 3 minus square root 5, and then plus 12. I don't know. I'm just okay. So that is it. Do not solve any further, because you might actually do it wrong. This is one of the good part about the FRQs, is that if you manage to get it down to what a scientific calculator can solve, you're done. Don't need to go any further. You don't need to try to solve this, because if you get it wrong, they'll take it as wrong. They'll try all the ways to make you get it wrong. So please don't give them the chance to mark you wrong, or give yourself the chance to make a mistake. So basically, is it extra parentheses there? But yeah, this is the final answer. I'm going to leave it here. But if you really want to perfect yourself and try to solve it to the end, that's just 2, or I guess even 2, 1 plus square root of 5. But again, don't try this, because you might actually get it wrong. If you get this wrong, let's say you do 2, forgot to factor out the 2, and you do that, it will mark you as wrong, even if you got this correct. So don't do that. Just do this. Alright, so the points for these. Alright, so this point, right here, would be, let's just do that. 1 point, 1 point, for fundamental theorem, and 1 point for correct answer. So yes, if you got this correct and you got all this wrong, you still get 1 point, which is pretty cool. But if you forget what this is, you get 0. So that's not cool. Alright, Part C. Part C, let's see what it says. So function g is defined by another fundamental theorem right here, but we'll get to that. So g of x is -2 to x f of t dt. Find the absolute maximum value of g on the interval to -2 to 5. So what is g? G isn't specified anywhere, but you can tell from the integral, right, that g is basically g is f's integral, which means f is g's derivative. Yes, let me say that again. Let me write that down. So right here, g prime of x equals f of x. Boom, you must know that. You must know that from the integral right here, because again, if you do this, if you take the derivative, if you take the derivative of this integral, you will get f of x with g of x. Again, derivative on both sides, you'll get f of x on the right because you cancel the integral, and g prime of x on the left because you take the derivative of g prime of x. So please know this, okay? And finally, you must also know that the absolute maximum value is kind of like when g is g prime or f, right, is 0, because that's when it stops increasing or decreasing. So how do we know that it is a maximum or a minimum? Well, what we can do is we can use basically the line test or chart test, depending on how you do it. This is not graded, by the way. They don't care if you whatever method you use, but I'll just use my method, kind of thing I invented. All right. So first, when does f of x equals 0? We need to know that. So let's go up here and see. -1, 1/2, 5. You can see that from the graph, right? -1, that's when f hits 0. 1/2 and 5. Okay, so let's say, so that means, therefore, if I can find the therefore symbol on here. Whatever. Therefore, f prime of 1/2, or just f prime of 1/2 equals 0. F -1, I don't know why I did that, equals 0. Ignore the space. Let me fix it. It's just like that. Sorry, OTD people. And f of 5 equals 0. So you know that because we know, again, g prime of x is f of x. Okay, so now what we need to do is basically we need to see from -2 to 5, we need to know that when, again, it is the absolute maximum, because that's what it's asking. So yeah, we need to find the maximum value. So kind of like what we can do here is, we can just plug in some value. So -2, again, g of x is 0. Why? Because you look at the integral up here, plug 0 in, -2 in. What's the integral from -2 to -2? That's right, we don't care about f, it's always 0. And g of -2, not f of -2, g of -2, because we're not dealing with the derivative anymore. Hopefully, again, I don't know what just happened there with my recording thing, but hopefully don't get confused. hopefully this makes sense. If not, pause the video. Just don't listen to what I just said because I was just messing with my recording software thing because it's like showing some pop-up. Okay, but okay, now that I got that fixed, all right. So yes, okay, g of -2 is 0 because g is that integral right here. So we put -2 in, and boom, that's 0. So again, we're trying to find the maximum value for g right here, and let's try again. The maximum value is somewhere along this line right here. So let's just actually plug in g of -1, and that's 1/2. Why? Because you substitute this -2 to -1 of f of t, which you can see is that little triangle right there. So that's 1/2, and g of negative, or actually we don't need negative now, we can just do 5 because we want to go to here now, equals 11 minus 9 pi over 4. Again, how can I find this? Again, g, the actual g function is just the integral. So we kind of established this through a, actually. Remember, we kind of talked about this, right? So that's where that comes in. And yeah, so basically we can see that this is clearly greater than this and greater than this, and there's kind of like a upwards trending. We go from 0 to 1/2. If we actually want, we can substitute like g of 1/2 equals, and if we just look at this, is that little sliver here, -1/4. And keep in mind, remember, 1/2 is a critical point. So this is the absolute minimum, which is pretty cool. We just found that, but that leaves this to be the absolute maximum because we literally identify all the critical points, which means these are possible candidates on where it could be the maximum. And finally, we defined that 5 is where it's the maximum, but it doesn't want the maximum. It wants the value of the maximum. So we'll have to, yes, now time to write the paragraph, or not just a paragraph, just a sentence. But on the interval -2, got to do the -2 less than or equal to x less than or equal to 5. Yes, okay. Again, we need this again. Max x. So the maximum value of x, again, not argmax. Argmax would be 5. So this would be 5. But we're not trying to find the argmax. We're just trying to find the max. Max g of x equals 11 minus this. I'll just copy and paste it. My computer is behaving so weirdly today. Alright, so that is the answer. Now, the points. You must first identify all of this. So this is a point, so I'll just write it here. Basically, g is, or f is the derivative of g. That is 1 point. And critical points. So max occurs when g of x equals 0. That's 1 point because, again, the derivative, right? That's when it kind of stops growing. And finally, the third point, obviously, is this answer. So 1 point answer. And you must say on the interval because that might not be the absolute maximum for -6 to 5. This is just from -2 to 5, which is what the question asked. Also, if you don't know this notation here, you can also just write alternative. So same thing on the interval. Let me just copy that. The absolute max is 11 pi over 4. So that also works. So just in case if you don't know what the max set interval is, but yeah. And okay, part D, we're almost done. Keep in mind, I'm on almost 26 minutes by now trying to explain this, but that's because I'm trying to explain the points and also because my software is acting up. But you have to do this all in your head, or not in your head, you have to write it out, but like just by yourself, obviously without anybody's help, in 15 minutes. So finally, part D, just the limit right there. So let's just do it. Alright, limit. I don't know if they have a limit thing. I think they do. I just saw that somewhere. Yes. Limit as x approaches 1, because that's the question, right? X approaches 1, 10 to the... Okay, yeah. So, fraction time. Again, half of the time me spending is just typing this thing. But, yeah. This is currently what I have working, so if it works, just stick with it. This is the limit. Alright. Well, now what is this limit right here? Okay, so let's just substitute in 1 for the limit. So let's just copy that in 10 to the 1. Well, that's just 1. F prime of 1. Okay. F of 1. Arctangent of 1. Alright. So this 10 to the 1. And what's f prime of 1? Okay. And think about it this. Let's come up here. F prime of 1. So the derivative of f. Yes. This is where they try to confuse you. Because part C, right? Part C, all of this crap, we just defined g prime of x to be f of x. Now, we're trying to find f prime of x, which is not the same as g of x. So do not get this confused. This is a completely different derivative now. Don't go back and try to say, oh, g of 1, where is that? Don't go there, okay? Just go back to the graph. We're trying to find the derivative of f now. And at 1, you can see clearly that is a slope of 2. Right? 2, 2. That should be pretty easy to identify. So that just equals to 10 minus 3 times 2, right, which is 6. F of 1, which is super easy. You just literally look at the graph. I forgot what that was. It's just 1. 1 minus arctangent of 1. And again, just leave it like this if you don't know what the arctangent of 1 is. By the way, this is pi over 4. So further simplification will be 4. Again, just for those who want the extra kind of like simplification, but this will be the answer. And finally, for part D, 1 point just to get this right here. If I can again highlight this, and I don't know why it doesn't. Probably because I'm underlining it. I don't know. Okay, but yeah, you get the point. The limit is just 1 point. Nothing else, nothing too fancy. Although you do need to get that right, but that's just easy, just to look at the graph. So yeah, basically 1 point, so 3 points here, 2 points here, 3 points here, 1 point here. So 3 plus 2, 5, plus 3, 8. So yes, a total of 9 points. If you do all of what I did in this video, you'll get 9 points. But rarely does one get 9 points, so do not feel disappointed if you don't. But if you do, congrats on you. Hopefully this video helped. If you enjoyed, please leave a like and subscribe. probably more FRQs coming out if I find something interesting. But I will see you in the next one. Peace out.